Well, let's go.
There you go.
Sorry for rambling on. So, welcome to the June 8th, 2021 session of TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week I've been working on a couple of things. I've been I had a session with Nathaniel and Kong and Scotty, and we talked about getting going on the FPGA code. So that was good. And I've actually done a little bit of work getting ready for that, trying to get a block diagram or a diagram that is FPGA centric pulled together. And I have some questions about that later. Anyway, that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things have been quite busy here. I'm supervising about 8 students this summer and working with Dev, of course. And things are moving along. So, of course, I met with Dave and Scotty and Kung about the Tangerine FPGA. And yeah, just keep moving along with everything. So W2NF, back to net.
Fine business. Next on the list, we have Dan. Go ahead, Dan.
Okay, thanks, Dave, and good evening, everyone. Well, this week, I guess all I did that's been productive is work on a script to install Python 3.9.5 on Ubuntu Mate for the Raspberry Pi. And I've got it working. I have a little bit of an issue in that my Odroid N2, which is what I really built it for, the power supply died on it. So I need to buy a new wall wart to make the thing work. But other than that, I've not done a tremendous amount. Been busy with other stuff. Anyway, back to you, Dave.
Well, fine business. And for something to break, that's about the least expensive part. Anyway, very good. Next on the list, we have Dev, KC3PVE. Go ahead, Dev.
Hello, good evening, everyone. So we have started our week here at the University of Scranton with a group meeting, and we have reviewed, there was a presentation by a member of the group, and we have set tasks for ourselves for this week, and I hope to fulfill my goal. Thank you.
Very good. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to you. Good evening to the net. Had a low level of continuous activity here. Did quite a bit of work on figuring out, there's complexities with regard to putting metadata into digital RF. And when you're trying to record data and you try and put additional metadata into the properties file, it rejects it, blah, blah, blah. So we have an auxiliary metadata file, which we're going to have to find out how to extract data from, which is not a problem. It's kind of just a bit shocking for the students that I have working on this. Worked a bit with Dave Witten on getting the right scripts to work for uploading, secure uploading of magnetometer data. And we've got something working on that. You might have seen, I posted a thing on the Tapper email about testing of magnetometer RF suppression. And what I discovered, we talked a little bit about in the past week or two about the noise that seems to be coming out of the magnetometer in some way. And I tested with putting ferrite chokes on either end of the Cat6 cable. That didn't make any difference. But what I found out is that a Raspberry Pi connected to a wall wart is actually not grounded anywhere. Okay, so what I discovered is if I run a cable, okay, from my heavy duty ground in the shack, which goes to buried rods in the earth and all of that, and ground the Raspberry Pi then the noise, most of the noise goes away. The birdie on 160 meters disappears entirely. The noise on 160 meters disappears, and the noise on 80 meters is cut by in less than half. So what I did was I found out, you know, the Raspberry Pi version 4 has a nice, it has an audio jack, but you don't have to use the whole jack. You can use just the ring of it to get a good ground to the Raspberry Pi. So I ran a cable from the ring part of the audio jack on the Raspberry Pi to my shack ground, and most of the noise on that's coming from the magnetometer is gone away, because now all of a sudden the shield of the Cat 6 is actually connected to a ground. Okay, so that's a lesson learned that we should bear in mind for, you know, in terms of, well, people who are interested in 80-meter DXing are really the only people who will be affected by this, but we need to make sure that you ground your Raspberry Pi. So that's what was learned today. Back to Ned.
Fine business. And yes, I also got my magnetometer rsync working as well. So there's at least two of us on there other than Dave. And okay, next on the list we have Bob, or excuse me, Bo, WB4GZK. Go ahead, Bo.
Well, thank you. Just sitting in tonight to find out what's going on. So I have no further traffic and I'll just keep listening.
Well, fine business. And if you find it interesting, please come back.
Thank you.
Next on the list, we have Kong. Go ahead, Kong.
Good evening, everyone. So this week I mainly tried to catch up with what Dave sent me over the email, which was the GitHub link to the project we've been working on, the TangerineSDR. And I also looked at the block diagram that he sent me on the Hermes. And also I also just received the Linux desktop from Dr. Frizzell. So this afternoon I set up quarters on that machine. So that is ready to be used. And that's pretty much it. And I might have questions later on the project itself.
Well, I have some questions for you for discussion as well later.
Thank you.
So next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello. Yes, I've been working with several people, Dave, Jules, Bill, I don't know, anybody else, trying to get some intelligible documentation on how to operate the magnetometer with the software that is currently available. And I was trying to standardize it. I'm not aware of any OS standard or anything else that had been decided. So I've been sticking straight to pure Raspberry Pi OS, you know, version of Debian. And but trying to keep things generic, try to keep things so they'll compile or operate on pretty much any machine, but once in a while I slip up. Actually, a lot of the time I slip up, but and there's been lots of bugs. And then making things a set of instructions that anyone can actually bear to follow. I think of the four of us using it at this point, no two are really doing it quite the same. And some of them for very good reasons, some of them, you know, just because of choice. But there's what I'm trying to do is a baseline using a Raspberry Pi 3 or 4 to operate the magnetometer. We can do whatever derivatives we need from that when decisions are made. But I think it's more, and I'm still working on that documentation. Nothing out there is the last word. So, and I I just made a few edits a minute ago. So we'll continue. It's just a reference and something for those who want to move ahead. There's something to work from. Also, Hillman has reworked some of what I put out there quite a while back, and we probably need to do another iteration of that into, I guess that's on a Google. Trouble is, we're putting this a lot of different places, and keeping them updated and versionized is something that worries me a lot. I'm putting everything into my GitHub and putting links into it from places. Anything else, anybody's welcome to ask me where that is, and we can move it elsewhere. But I'm going to be keeping a copy there so I can kind of keep track of my versioning. There's really just no other way with Google Drive or things like that to do that I'm aware of to realistically keep the version straight. So, but that's a work in progress, bigger task than it really sounded like it would be, and I hope it's useful. Over.
Fine business. And next on the list, we have David in one HAC. Go ahead, David.
Can you hear me now?
Yep.
Hello all. I haven't had a chance to respond on the magnetometer interference, but I do have experience to offer. I'm not at all surprised at what has been found. We found very similar in our experiments, installations out in the field. A lot of noise gets conducted out of cables on the outside. And as I've heard it put, we are our own worst enemy. That isn't strictly true, but a lot of our noise
David, your mic went out.
Hello? There we go.
Now I can hear you, but it's a different kind of mic.
Now, okay.
Okay, I can hear you.
Well, all right. I don't know why this keeps cutting out. Earphones are doing funny things. Anyway, we have a lot of installations out in the field. We know that noise gets conducted out the outside of the cables. We've done a lot of work putting very heavy chokes on them with some success, taking a cable and wrapping it around a large toroid of appropriate absorbent material, ferrite. You want to keep any electronics that you can inside a closed metal box, of course. And that's one thing that we haven't been doing, I think, with our Raspberry Pi systems. And then, yeah, so the noise is, going out rather than necessarily being generated out at the far end. I guess I was expecting the magnetometer to generate some noise of its own, but it sounds like it's more the processor noise going out. One thing that we find in the snow is it makes a very good inside out transmission line with the dielectric of the snow around the cable. It's amazing how far that noise can go. It can go a mile. We've got stuff at like 1,500 feet to 2,500 feet in Antarctica at South Pole, and our computer noise gets out there. We've learned to null antennas, for instance. There was another instrument that is an imaging rheometer that we've coexisted with. We've had to null our antenna to their cable to get the noise out. So this is a known problem. There are ways that we've used to take care of it, but yeah, shield everything and choke everything. And so, yeah, it'll be interesting once we get these out in the field with receiving systems, what we end up getting. Unfortunately, I have receiving capability here of 160 and 80. I have not tested it. I also don't have shielded cable. So that might be a worst case that I can offer to see what radiation we're getting. But yeah, for this project, we're certainly going to want to get a good handle on whatever noises are being generated at the end of the cable, but more importantly, it seems to be at the processor end. So back to net.
Well, fine business. And next on the list is, let's see, Gary, AF8A. Go ahead, Gary.
Good evening, everyone. Just copying the mail, so back to net.
Okay, fine business. And next on the list is Hillman, KD2MCR.
Good evening, everyone. I've been working on the documentation mostly. As you can see, as I shared the document with others. Currently, there are 3 documents. One document focuses more on installation and operation, which is kind of main document. And then we have one document that talks about sensor housing, which Jules provided. I guess Jules is not here today, but thank you very much for the documentation. The third documentation is what Dave Witten provided for the software operation. So I'm thinking whether I would like to ask you guys whether we have to integrate all these documentations so that we can have one place to look at, or we just keep 3 documentation as it is. So otherwise, I'm still working on it with some more pictures that would help readers understand what's going on. I think the documentation is going to be almost done. Although I also have to add some more description, but I think most of the parts in the document are very close to being done. So that's what I've been working on. Second issue that I want to share with you guys is that, well, I guess Nathaniel is already know about this, the Eclipse Project in Antarctica. There are a group of scientists who are interested in, ionospheric effect during eclipse. And one idea that came up from one of the meetings that I attended is that we can provide the Grape for the BAS, British Antarctic Survey, because one of their stations is under the totality of the eclipse. So it will be interesting to operate one of our HF receiver system down there, if that's possible, to deliver one of our Grape system down there before the eclipse starts, which is early December. I guess to be able to be deployed, we have to ship it somewhere by, I guess, October-ish, November-ish. So that's something that we have to consider. That'll give us very good opportunity to make our effort more visible, but also scientifically it will be very beneficial and very synergistic. So I'll be talking with Nathaniel later. But that just came out from the meeting that I just attended today. So
yeah, Yeoman, the person we should talk to is Christina Collins, because she's already working on hardening one and preparing one for McMurdo station. So we have got 2 options. One is to take that one that's headed toward McMurdo and redirect it to BAS. The second option is I have the base, now that Christina has experience doing this, I have a base platform that I could send her a second one, and then she could potentially put together a second one based on her experience with the first.
Yep.
So, but she would be she would be the best person to do this for Antarctica.
Yep. Well, also, I have a very good relationship with German institute, AVI, who operates a station down in Antarctica, which is kind of close to British Antarctic stations. So, you know, they might also be interested in putting one of our systems down there. Although that station is not under totality, but still, you know, I guess simply speaking, the more the better, I guess. So
yeah, I would talk to Christina
Sure.
and see what she's capable of, because she's got the most experience putting that together right now.
Yep. Okay. But anyways, yep, that's all I have. Back to Ned.
Okay, and I will mention we have a website, TangerineSDR.com, which we can put documents at. Not everybody has posting privileges. One way that you can do that is exactly what Dave Whitten suggested. If you put it on your own GitHub, I can point a link on the Tangerine SDR to your GitHub to the actual document. And then that way you have control over editing and versioning, but we have it available for other people to read. So just contact me if you want to do that with some document you want to work on.
Yeah, and I meant to say, yes, it needs to be in one place, at least have links available.
Yes.
Otherwise it just gets.
Yes. We're trying to,
unmanageable.
originally Scotty asked me to pull together a website for that purpose. So, and the website was designed that way. So next on the list, we have James, KG4DSG. Go ahead, James.
Good evening, all. Just listening in as usual. I did have one quick question for Bill. You mentioned with the noise issue, you mentioned shielding on the Cat6. Are you using shielded Cat6 cable?
Yes.
Yes.
You
Yes.
are. Is the Raspberry Pi housing shielded or grounded?
The
Or housing.
magnetometer module is.
Okay, so the grounding, the shield on the Cat6 is grounded at the magnetometer.
That's why
Yeah.
you grounds the Raspberry Pi. If you ground the
Okay.
Pi, then it goes up through the connector and connects to the shielded connector on the magnetometer, and then everything's grounded. Right,
So-
Bill?
That's my understanding. I mean, well, you can hook it up different ways, but from my understanding, the best way to do it is to ground the Cat6 just at one point, closest to your shack ground. And then, so you don't want to have a ground loop
Right.
where your Cat6 is grounded at both ends. You want to ground it at the Pi.
So
But there's
Also-
a jumper on the board to connect to the Cat6 shield or the Cat5 shield. But on the far end, there's basically no ground, even if you put that jumper on, because it's inside a pipe, right?
Yeah, and I think that's what you want.
That's
Yes.
what you want, because otherwise
No,
it turns
you
into an
want-
antenna.
You want it grounded at both ends. You don't want it floating.
Tom had strong opinions about that.
So
RF, you want it
Okay.
grounded.
Well, so the
audio,
recommendation
you
going
want it
forward is going to be grounded or shielded Cat6 for the magnetometer?
yes, but that
Yeah.
is not an internet
I know.
connection. That's
I know.
just a
But no, all along, we've really discussed essentially Cat6A, which is kind of double shielded, I believe, Cat6, which allows us to pass the grounding through our connectors all the way up the chain. And yes, it was designed presumably to be grounded at one end or the other. And I'm not an expert on the whys and wherefores of that, but Tom McDermott had strong feelings about that
Still,
subject.
even if you put the jumper on the far end, all that does is connect the shield to the logic ground of the magnetometer board. It doesn't actually do any grounding because it's a plastic pipe.
And it doesn't really need to be. You just want complete metallic envelopment of the electronics at the far end as best you can accomplish and connect that to the shield. So David's got it just right, I think.
So
Yeah.
you put the jumper on both ends then?
Yes.
Yeah.
Okay.
Yeah, otherwise you make the magnetometer an antenna.
Okay, I just wanted clarification on that. Back to the net.
Okay, and next on the list, we have Jay. Where'd you go? Oh, WB8 SBI.
Good evening, everybody. Not a whole heck of a lot here. The only problem I'm having these days is actually a laptop problem. And that is when I powered down my laptop and disconnected the power supply, the power brick, and then I went to plug it back in, it didn't work. There was no indication that the power was getting from the brick from the power supply actually into the laptop itself. I checked the brick itself and it was working fine. So, and after having had this experience a couple times, there's something about my laptop, and I don't know if it's the connector, the power connector, or if there's something internal in the circuitry that when the external power supply goes away, it stops working until it decides to start working again. So and so I've ordered a new laptop, and I'll demote this one to spare or just make it my FTH station or something like that. And then I just have to go through the process of commissioning and configuring and putting all the programs onto my new laptop. But that's really weird. Has anyone ever had something like that happen before?
I've had issues where the battery on the laptop is problematic and was making poor contact. And so when it was on AC, everything worked okay. When you unplug the AC, the battery would work for a while, and then either the battery would suddenly fail or a battery contact would open and it would crash the computer, of course, would lose power then. That's the only direct experience I've had.
And I've had connectors actually come loose from the PC board. Like if you sit the laptop down and bend the connector up, it breaks the solder joint inside, and so you can't ever charge the battery. So if battery runs down, then the laptop's no good anymore.
Yeah, I think right now it seems to be functioning. It seems to be okay. The battery is fully charged, but I'm not taking any chances. So I'm leaving this thing plugged in. I can power it down, which I have done. So I can do a complete power down and shut off, and it will turn back on. But until I get my new laptop, it's like, I'm a little bit hesitant to move this thing and to do too much with it. Other than that, saw a real interesting film tonight, courtesy of the Southeast Michigan chapter of the IEEE on Nikola Tesla. And one thing I didn't know of historical note is that after Tesla died, his patents, that Marconi used his patents, and the U.S. Supreme Court ruled that Marconi had usurped the patents, and that Tesla was the proper owner of many of the patents that Marconi used to accomplish all the work he did. Now, it was after Tesla died, so, and he had no estate, no heirs, so there's nothing, no money could change hands, but it was a historical note that Marconi used patents without permission to accomplish much of what he did. And that Nikola Tesla was the proper owner of the patents, and that is per the U.S. Supreme Court. So little historical note there. Other than that, 73 doll, back to net control, and get ready for field day.
Okay. Next on the list is Jim K4BSE. Go ahead, Jim.
Good evening. Well, Not a lot here. I've been trying to clean up a little bit of the documentation on the Grape 1. And sent some work out to Gary the other day. I had been saying I was going to do some assembly notes on the PC board, which I did, but they kind of blew up on me a little more than I expected. And so, Gary, I hope you can make something of those. I guess you have an understanding with Christina now, I guess, about where all that's going to be published. We can talk about that Thursday, but just so noting, I do plan to, there's one picture I want to take I think may help some. Kind of walking a fine line there between documenting it thoroughly and not really encouraging people too much to try to build a thing because the thing kind of took on its life of its own that nobody intended. And don't want people doing the good work on the next version of the Grape to get distracted by having to support this one. That's about it. Back to Ned.
Fine business. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. There was some really good discussion about the noise issue with the magnetometer. These were a lot of issues that I've ran into with my VLF receivers. Bill, I was wondering, the shield of your Cat 6, that's definitely grounded, right, on the connector?
To the best of my knowledge, yes. The thing is, I bought a commercially prepared cable, and I had to take one end of it, on the magnetometer, the buried part of it. I had to take the cable apart in order to run it through the waterproofing and everything else. But on the side that's in the shack, it's just as it came from the factory, and it was a shielded Cat 6 purchased that way. So, is it grounded? All I can say is, I guess so. I mean, it acts like it is, because it does have, whether the case is grounded or not, definitely impacts the noise. You can see it right there in the waterfall.
Okay. Yeah, because when I do my VLF receiver installs, I make sure to ground the shield on both ends. And for the audio, I use isolation transformers, and for power, I use isolated switching supplies if I'm supplying power from the inside. If not, then I'm supplying it from a battery on the outside. So that was that kind of made me wonder, is there a possibility that we could use optical isolation on both ends of the magnetometer? That could be one way to mitigate noise. The other option, the other thing that I was wondering is why I2C was used instead of something like a RS485 ASCII serial.
Jonathan?
Somebody's phone is ringing.
Oh.
Jonathan?
Yes.
Just as a point of interest, and nothing I want to be held to,
Yeah.
but I have a 0.5 kilometer of actually plastic fiber. It requires 2 pieces, so I could get 1/4 kilometer with it, using some things, some small repeater or some small devices SparkFun was selling. Unfortunately, their setup only uses RS-232, we were interested in, for a variety of reasons, in I²C. I might have to convert, but I was planning to experiment. In fact, I've done a little bit of experimentation with this fiber setup, a lot cheaper than the, single mode long haul fiber or something like that. This is it's actually, it's a what is it? It's a 2.8 millimeter. Is that right?
Dave, I think it's a 1 millimeter polymethyl methacrylate.
Okay. Yes. That. Okay. You've seen it. Okay.
Yeah.
I do
We
have
used to
that.
use it at the throughway for all of our RS-232 runs out to toll plazas. So we use tons of it.
Oh, really? Okay. I had planned to ask you about it. And in any case, I planned to play with it and see what that did. Of course, it requires a mechanism to power the remote end because you have no electrical connection to the, it's all optical, but it does have the advantage of being quiet.
Yeah,
that's
one
just
of the
something.
things, one of the things I noted was that we didn't see any spectral lines at the clock frequencies. And to me, that indicates that we're not seeing I2C noise.
That's great. This bit of playing around is just curiosity on my part, but it is an option in some situation, might be an option in some situations where there were some other problems.
Okay. Yeah.
Since you asked.
Yeah. Tom, that's a good point, because I was wondering too whether that was I²C noise or whether that was noise from the clock of magnetometer.
My guess is it's actually noise conducted down the cable that's from the Raspberry Pi, probably not anything to do with the magnetometer.
Oh, okay. Well, right, and Bill's experiment kind of validates that.
Yeah, that's my takeaway from it.
Okay, yeah. All right. Good. Well, So yeah, in my I'm experimenting with an optical audio link with my VLF receivers, and I also use audio isolation transformers, and I use either magnetic or optical isolation for my VLF receivers. That's what kind of sparked my thinking about this problem. So it's a good thing this issue came up, because it's probably going to come up again, and it's good to try to understand how to mitigate this problem, because it's very important for VLF, and it's also important for things like the magnetometer. Other than that, I've been working on a little tester box for my active VLF antenna that I'll be installing at Nathaniel when he gets a chance to install his magnetometer. What it's going to do, it's going to power the active VLF antenna, and it has an LM4881 headphone amplifier and some connectors and a volume adjustment and headphone jack for testing and making sure that the active VLF antenna is working and producing audio like it should. So I had a spare Hammond enclosure. They're so handy to have. I had a spare one, and I bought this little headphone amp board for that purpose. So I'm working on getting that ready. So if there are issues with the active VLF antenna and it's not getting audio to the Raspberry Pi, this can verify that the VLF antenna itself is working. So it's a good tool to diagnose any issues. Other than that, I have nothing to report. Back to the net.
Well, fine business. And let's see, next on the list is Joe, W7LUX. Go ahead.
Stand by one. Okay, good evening, everybody. Been just monitoring WWV with the Grape and responding to Christina's request for some ideas about interference. I've got quite a few standards running here, 5 and 10 megahertz standards, and they do interfere with the radio when I've got auxiliary equipment connected to the standard. The standard just sitting there running by itself with no connections to the signal port. Seems to not bother the radio, at least not that I can tell. However, the problem is that while there's no obvious indication of interference, there may be insidious interference in that I ran some plots back in the last 2 days of May and the first 2 days of June, and the first two plots in the last of May had the interference due to equipment connected to the standard. The two in early June, June 1 and June 2, did not have that interference. I disconnected the stuff from the GPSDO, the HP GPSDO, and I saw no more of a trace of interference, and the signal amplitude, or the amplitude of the Doppler shift, was significantly larger on June 1 and 2 than it was on May 30 and 31, when there was considerable interference. Anyway, that's what I've got, and just sitting here, I'm late because I was typing a reply to Christina. Anyway, very good evening to everybody. Go ahead, Dave.
Okay, and next on the list, we have Jules, K2KGJ. Go ahead, Jules.
Okay, was fortunate in being able to install Dave's new firmware this week and get on to the exporting my data to his setup. That seems to be working well now. And thanks, Dave, for all the help on that. Finally got the path straight. With respect to noise on the Cat6 cable, a couple of things. I think I sent out a scope image earlier in the week that looked at the transient current at the far end, at the remote end. This is on 100 and some 10 feet of Cat6. That the I2C differential extender at that end draws when it's transmitting back to the local. You can that transient appears on the cable, on the power lines, and can be substantially, as you saw on the scope traces, substantially reduced by an appropriate size low ESR capacitor on the 5-volt line at the remote end. Okay, number one. Two, when we first started playing with the Cat5, shielded Cat5, the first setup I tried had the power and ground, the 5-volt power and ground combined on, shared on two twisted pairs. That is, I had each twisted pair carried power and ground, and the two of those were placed in parallel, so that the power and ground was actually over a twisted pair, not as in the current situation where there are two separate twisted pairs, one for power, one for ground. I have not had a chance to do an analysis of radiated EMI, not conducted EMI in the shield due to common mode currents, but radiated due to the possibility of that separation of 5-volt and ground into two separate twisted pairs. I'm going to have to restore my original connection and try that, but I'll just pass that on, and that's it for here. Back to the net. Go ahead.
Well, fine business. And next on the list, we have Khan. Are you still there? Go ahead.
Yeah. Hey guys, I'm still here. I'm participating in that the Eclipse thingy right now. And I do get a lot of noise. So this this whole grounding thing is pretty helpful. I know I had to ground some stuff, but I didn't. So yeah, I guess I'm gonna have to do it. So I just bought some shielded Cat 6 cables just like 2 minutes ago. So, and what is it? And yeah, I'm gonna, there's a few other things I want to do too, but when I do it, I'll update you guys next week or something. But as for now, yeah, that's it. Back to that.
Okay. And next on the list, we have Mike, AAAK. Go ahead, Mike.
Oh, thank you, Dave. Yesterday, greetings to everyone listening. Yesterday, I completed my Excalibur, my second Excalibur.
Yay.
And it doesn't work. So that's another troubleshooting project. I've got 3 receivers going on data right now. I was very disappointed to realize that Audacity could only run in one instance. With the LinSDR, I was set to do 6 frequencies on one device. But
well,
back to you, Dave.
Okay. And I did see Bill N8ET jump in there. Go ahead, Bill.
Yeah, I've got nothing to report. I've been up working at the boat and came home for one day, took my wife for the eye doctor's appointment, and I headed back to the boat tomorrow. So nothing here, and missed most of that anyways. Back to you.
Okay. And next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay, thanks, Dave. And let's see, this week spent some time working with the CAD guy on length matching for the differential pairs. Went through the rules with him, and he's off doing the length matching now. We've got all the physical connections made, and got almost all of the pins connected up to things in the FPGA image. I've got a little bit more to do there. And the CAD guy, I think he thinks he's going to be done by the end of this week with all of the length matching and cleanup and everything that we have. So then we're back down to waiting for the part, the one last part that I'm having trouble getting, which is the FPGA. And that's a whole nother story that I won't bore everyone with, but it's the comedy of errors on Intel's and Arrow's part. So we're still working that issue. And then, of course, there were some unrelated fires this week on other projects that had to be taken care of. So it's been pretty busy this week. So last week, I should say. So back to you, Dave.
Well, fine business. And now we have Tom in N5EG. Go ahead, Tom.
Okay, very good. Real quick, can I get control to share the screen? I have 2 slides. Oh, okay, does this slide show up?
Yes.
Okay, so I've set up a measurement for looking at spurs in the receiver. And this, I prototyped the test on Hermes, but we'll move this test over to Tangerine when we get to that point. The Hermes receiver's got a 50 ohm resistor feeding the receiver, and there's a wide band output on Hermes that puts out 16,000 samples, and then some dead time, and then 16,000 samples. And it has to do that because it only has 100 meg Ethernet, and it couldn't keep up with wideband samples at any faster. And then we look at the spectrum through an FFT. The samples coming out are real. So I throw away half of the vector samples and keep half. And the box here that says array of Iir filters, that's 8,192 Iir filters in that block that filter each of the FFT output channels, and then it goes over, it gets turned into magnitude and then turned into dB and a vector sync. And this is what I actually measured on the Hermes. And you can see over on the left side is the DC component. That's the offset voltage from the A to D converter. You can see a little bit of leakage down here in the AM broadcast band, even though I've got a BNC 50 ohm resistor connected right to the input jack. The AM stations still get there. But you can see a couple of pretty substantial spurious components. And these are signals that come out of Hermes even when there's no input signal at all. And I think these are fairly well known. You can see most of the signals down there in the grass fall away because they're averaged by those low pass filters. But the spurious components don't decrease when you filter them. And so I'm hope this is the test that I think folks were looking for in terms of spurious responses on the receiver. So if there's any comments about this or the methodology, I'd appreciate it. And I can continue to work on this test. But right now, I think this may be what is useful for the Tangerine. And that's all I've got. I can unshare now.
Okay, well, that brings us to the end of the list, unless anybody else has jumped in there. I've looked up and down. I can't see anybody we haven't called on. Oh, there's Tom Yarnish. I don't know if he wants to make a comment or not. And no response, so we'll go on. So we're open for general discussion.
Tom, on your graph there, you could expand out the lower scale and maybe see some switch mode power supply spurs or things like that. Is that true?
I'd have to look at it. The resolution is limited by the fact of by the vector size that the Hermes puts out. So I have 7.5 kilohertz between adjacent FFT bins. And so I'm somewhat limited as to how much I can process due to the interrupted sample nature of the receiver.
So on gigabit Ethernet, if we could give you bigger packets, would that would you have enough horsepower to process that?
Yeah, we'll have to see if we can get the wideband samples out from the receiver at full rate at GigE. The way Hermes did it, I think, is clever. They knew they only had 100 meg Ethernet, and they need GigE to get the samples out in real time from the wideband receiver. So their approach was pretty clever, given the limitation that they have.
But Hermes has GigE, doesn't it?
Yeah,
no.
But
if they implemented it, I mean, it's
they
got the chip.
they didn't change the wideband after they built it.
There's a second problem. The gigabit Ethernet on the Hermes module doesn't work properly. There's a power supply issue on the Hermes board.
Oh, right.
It makes it not function correctly at gigabit.
It's that little FET regulator or buffer chip, right? Is underpowered, under heat
Right.
seeked.
And so I think that the FPGA image was also too small to accommodate. You know, there were 3 or 4 things that ganged up that prevented that.
Yeah, but we'll be able to generate UDP at a gigabit speeds. So I think I figured out at 16 bits IQ, that's about 20 megahertz with the bandwidth. So if we were to make it just real data, then we could give you a lot more bandwidth.
Well, you only have real data coming out of an A to D converter. That's just the raw samples. So
right, but if you want just raw samples, you don't want filtered anything filtered.
Well, in the wideband mode, which is what this test runs, you just want the raw real samples from the converter. That's how you can characterize the converter.
So we could run, if that my calculations right, gigabit Ethernet is about 100 megabytes per second, right? So that's about 50 mega samples per second, plus minus the overhead.
Well, so one converter puts out 2 bytes per sample, right? Because it's a 14-bit converter. So 2 bytes times 122.88 megasamples per second.
250 megabytes per second.
Right, and times 8 bits per sample is about 2 gigabits per second.
Well, it's 2 bytes per sample, right? So it's
Right. So it's 2 gigabits per second.
right, which will not fit in our 1 gig. So what do we do then? Just give you every other sample? What would be the best way to
I'll
give
think
you a
about
burst?
Yeah, I'll think about it. If we can get longer bursts than 16384, we can get better resolution.
I think we could easily do that because we have a big RAM on there. So
Yeah. So if we can get a long burst and then dead time and a long burst and dead time, we can zero in a lot closer.
Scotty, is the USB available?
yeah, we could use USB 3 and that runs at 5 gigabits. So that might be a way to just shove raw data out the USB port. And
Yeah, so we can, on Hermes, I wrote 2 different drivers. I wrote a different driver for wideband than for narrowband. And we could do the same thing on Tangerine, just have a wideband driver and a narrowband driver.
And that would be interesting if we put, we could just shove out full speed IQ data on the USB 3 port and let people use it for what they want. We could do that in parallel. Remember, FPGA is all parallel, so that really, as long as we have space in the FPGA to do that, which is not going to take a whole lot of processing, because USB 3 is just a FIFO. So you set up the endpoints and then you just shove the data out, and it's in hardware speed. So you're talking about it takes a few registers. That's it.
Yeah, so there's a couple of other options since you have multiple, but we can talk about those later. I just think either getting full at rate samples or long bursts, either one. Well, I think let us characterize how the converter is working.
Yeah, because the question I really had was if I could give you full speed uninterrupted data, can you process it that fast?
I'm not sure. The GNU radio is doing a pretty respectable job, handling 8,000 filters in parallel, doing things like that. So we may, it probably depends on how powerful the host is.
You're probably not running this on a Raspberry Pi, right?
No.
It's running on something with a few more horses under the hood.
A few more cores.
Well, Scotty, after our discussion the other day, I was looking at making some sort of a diagram of what the DE is doing, and I was reading Bill's documentation, and there were a couple of questions that came to mind about that. Why are we using a discovery packet from the HPSDR when none of the other stuff conforms to any of the HPSDR protocols?
What you're talking about our board?
Yes. So why don't we just make our own discovery packet?
We could do that, but why
I think we should to avoid
confusion.
confusion.
Well, why make it different? Even if you make it the same, then if some brave soul plugs their Hermes board into our network, we can at least recognize what it is.
Well,
we might not talk to it.
The one issue right now is we're colliding with other boards that are undocumented.
How do you mean?
So we picked
1024, right?
Well, one thing is the thing is all in binary, the command that goes back and forth. And we picked number 7 for our which was the last of the documented boards. But if you look in LinHPSDR, there's about 14 of them.
Do they all use different hex numbers, or they all pick 7?
Yeah, it basically tells me that my simulator, which is trying to be a TangerineSDR, is an Orion.
It's just because they made their own. Okay, I'm not
have the confusion that Hermes Light is also building boards and using those numbers too.
So I have no problem with that. So you're saying maybe we would send a question mark instead of an O2 or something like that, right? Is that what you mean? So we send an ASCII character.
Yeah, and Bill built the whole thing with ASCII characters. Why can't we just use an ASCII character
you can do
set for the discovery? And I think it would be simpler and more straightforward.
And then if we want to discover Hermes boards, then we can.
We could build a Hermes Discoverer.
Yeah. Or we could reprogram the Hermes to use our.
I mean, we already have that code, so that's not a problem.
Yeah.
That was the one thing that just didn't seem to make sense.
That's fine. It's evolved out of that. So
Yes.
if it makes sense to not do that, then, I mean, we need the function. We don't
Yes.
necessarily need to be compatible.
Yes.
Yeah,
I think
mean,
that's
the reason I did a lot of that stuff that was the same as the older system was so that we could use John Melton's very nicely crafted discovery. It's very error tolerant, and
Yes.
it doesn't hang up, and it's able to deal with an awful lot of things. And it was so nice to be able to use that and be. And
yes.
But you couldn't you ask John to change a couple of characters in his?
Oh
if you
yes, he
recall,
can
and
add.
he'd be-
I mean,
He can add
we
our
got-
stuff too.
Yeah, we got the source. I mean, we got the source. We can make it do whatever we want to.
Yeah.
If you know.
Well, I mean, whatever makes sense. I'm not certain things I'm really enamored of, but this isn't one of them.
Yeah.
So
that was one thing. I am trying to figure out essentially in the FPGA code, they talk about the there being a state machine. It's not really a state machine, but the Phils were both enamored by state machines when they started.
the Phils. Oh, both Phil Covington, you mean, and Phil
Yes.
Harmon?
Yes. And so they were trying to build a state machine in FPGA. And it is a state machine, but it's not really a full complete state machine.
I got to tell you a little anecdote that has to do with state machines, and it might make it, I don't know, maybe it'll make a little sense, but we did this project for Honeywell, and it was, I can talk about it now because, well, maybe I shouldn't talk about it now. Anyway, it doesn't matter what it was. The fact is that they had strict software requirements that we were not allowed to use software. Okay, we FPGA code was okay, but if you wrote software, then it had to be certified, and it had to be tested, and all the loops had to be verified, and every instruction had to be executed, all that nonsense. So, but we really wanted to put a Neos in the thing because it was the easiest way to housekeep and steer things. Even though the high-speed stuff was done with state machines, we had to have a Neos because it was just the easiest way to do it. So what we did is we told the customer that a Neos processor is a predefined state machine. And in fact, it is kind of. I mean, it has known states, it has known instructions, it behaves in a particular way in response to each particular instruction, and it's all defined. So all it is a canned state machine. And they accepted it, and they allowed us to use it in housekeeping.
Well, and essentially what I'm trying to do is look at Bill's documentation from the DE side and saying, okay, I get this. What do I know? What do I don't know? What do I have to wait for? And I've been going through his code and
Bill's code.
Bill's code. Bill made a simulator, and I'm trying to be able to explain it to Kong what he needs to know to write the FPGA code. So that's what I'm doing right now. And
well, I wouldn't get too wrapped around the axle on that because I don't really think that that's the best way to do it.
No, but there are. So when you turn it on, you're in like Bill said, a no-op state, and then you're going to have certain things, a discovery coming in, then you know what kind of radio you're talking to, and then there will be the procedural configurations coming in, and then the data lines coming in, and then the dump of INQ basically. And so you have to be well aware of where you're in that sequence and what you have to do. And
Well, and
since
you have to keep track of port numbers and IP
Yes.
addresses and things that are going to be really hard to do in
So-
state machines.
And what I'm trying to do is figure out a table or some sort of an organizational way that could be programmed in Quartus that will do what Bill's C code does.
Well, but you build simulator code.
Yes.
Okay.
So that's what I'm busy working on.
Well, so but you're talking about pretty much how is the NEOS going to control things as opposed to
Yes.
actually registers in the.
But also
FPGA.
keep track of where they are.
Well, but that's easy for a processor. It's hard for state machines. They get
Yes.
complicated really fast.
Yes,
so,
I know.
So my opinion is that you take the state machine and you integrate it with the Mac, okay, the Ethernet
Yes.
Mac, and you may take another state machine and integrate it with other pieces, and then you have the NEOS processor talk to all those state machines and steer them
Right.
and tell them how to behave. And
But essentially you need some sort of a there is a sequence that Bill is very nicely detailed in a document. What we need is in the FPGA a way of keeping track of where we are in the sequence, and it's just not.
But isn't that going to be what the NEOS processor does? I mean, it's almost a no-brainer. If you
Well, it's
you can take what
close.
Bill's already done and just,
Yeah.
I mean, it's you're going to have to tie it to the hardware some way, which Bill doesn't have because
Yes.
there's no Mac and all that stuff in the FPGA. But so are you trying to define the line we draw, the interface between the FPGA fabric over here and the NEOS over here? Because the NEOS is going to really run Bill's algorithm, and the FPGA code is going to do the high-speed data transfer. So you want
Well-
to keep the NEOS processor out of the flow. It sits on the side and directs things, but it doesn't get in the middle of things because it will not be able to keep up.
Yeah, but essentially we need to be able to make a diagram that we can give to Kong to understand where all the pieces are and how they connect.
Okay. But still, I mean, you don't really have
And we
to
don't
get
have
into-
that right now. I did sort of one for the Hermes, which is much simpler.
But you don't really have to get into the details of the state machine to draw the diagram because the state machine just controls it. The NEOS steers it. So,
well,
just like when you draw a block diagram of a processor over here, the state machine over here, you really don't have to put the code. You don't have to tell me what the code does, right?
So a Hermes just turns things on and off at certain state, and there is a sequence, but
Right.
Bill's depends on communication back and forth. And so it will take a little more complicated.
Right, but then essentially what you're going to have is you're going to have a hardware block diagram that's going to show what the blocks are, but then you're going to have a firmware diagram for what goes on inside the NEOS that shows what steps it has to do to control everything and sequence it, right? So now you've got it split into two pieces, which I think is much easier because try and put it all in one piece like Phil did, hardware block, and then describe how the hardware block works.
Right.
That's hard. How about we put a hardware block over here and a NEOS here, and then let's describe how this controls the hardware block. And that's the piece that I think you're missing now is how does the firmware in the NEOS, what does it do? How does it steer things?
Well, yes.
Or am I oversimplifying things?
Well, I'm sitting down trying to read through several different documents,
Yeah,
and
I
trying
think
to
that's why
make sense
Phil-
of how they all fit together
That's why Phil's code, I think, is good to look at it to a certain extent, but it rapidly becomes.
But I'm not focusing. I'm focusing right now on Bill and the stuff that I get out of Intel that tells me how the FPGA and the NEOS work.
Okay.
And
Well,
I'm
so that
trying to
sounds like the
make
right
sense
thing.
out of those
Yeah.
things.
Because basically the NEOS code is going to run things the way Bill's running things, only with different hardware.
Well, yes, there is a C compiler in the NEOS,
Right.
and it is GCC. The,
So
the
like I
issue
said,
is
the-
you don't have the same components that you would have on any kind of Linux machine. There's a bunch of things missing.
Well, you have a lot of, you're at a lot lower level
Right.
than you are on a Linux machine, where you can just issue a call and to some function and it takes care of everything for you. Well, now you have to do that yourself because there's no function.
Yes.
So then actually you start Bill's code's just the top level, and then you have to figure out.
We have to figure out all those other pieces and how to
Right.
do them.
I don't
And
think it's
and
gonna
that's
be
what I'm
good.
trying to do in an organized so that we have a map where we're going.
Well,
Right
that'll be
now, we
really-
don't have a map.
That'll be really useful if you can do it. That's a hard task.
Yeah. But that's what I've been working on and trying to get my head around. I'll probably be sending Bill a lot of questions. So.
Well, Bill has enough
I
monitors
remember
back
that what I developed was based on that long conversation, Scotty, that you and I had when we were in Orlando.
At Hamcation, yeah.
Yeah, a year, 2 years ago, whatever the hell it was. Anyway, yeah, I mean, I basically tried to implement that based on what that discussion was that we had.
Yeah.
And it was based on some white paper that somebody else had done. It ran to many pages, but it turned out a lot of it was just general discussion, if you remember correctly. Anyway.
It was kind of based on Protocol 2, but it was not Protocol 2.
Right,
So-
yeah. Like a simplification of Protocol 2, but anyway.
Yeah.
Yeah, I guess the problem is that, I mean, the algorithm doesn't require a lot of sophisticated stuff. It's just that it depends on being able to get certain things through, you know, off a UDP or TCP or whatever.
Yes.
I mean,
And that stuff isn't all there.
That's because you're doing a bare metal installation.
Yes.
You don't have any drivers or anything.
Yeah.
So.
I mean, but that was going to be an issue no matter how we do it, because you're anticipating you're going to have this, at the very least, UDP communication between the different parts of the system. So
And we'll just have to do this once.
Right, but we had a discussion about this about 3 months ago. We have to find a way to communicate port numbers in an unambiguous way, because socket programming has some restrictions, and we were missing some of those things. So
yeah,
this problem's gone around once or twice already.
But I think, Tom, hopefully that protocol that Bill and I discussed a couple of years ago at Hamcation took care of that. I'd like to think that we took care of that.
Well, there's missing things.
Missing,
Okay.
yes.
There are definitely missing ports that we have no way to find.
Yeah.
The idea is that you request a port and you get assigned one. You can't assume that I'm going to have access to any port by default, except for the listening port.
I got to have a way to ask for it.
Yes, there's no way to ask for it.
But I thought isn't that in the protocol, Bill?
I thought so, yeah.
Well, okay, we can't, there's a number of port numbers. The first one, I forget what it was, port B. I didn't have a way to find out what it was without doing a listen all. And you can't do a listen all unless you have sudo.
Okay, well, then that's the omission,
pile of
Tom.
things that unroll.
That's an omission then, because that wasn't the intent. The intent was that everything's defined. The only predefined port is the one you listen on, and all communications occurs on assigned ports after that. You request and you get one.
Well,
so if there's missing some way to request one, then we got to fix that.
Precisely.
Well, we presumably we can send a port in that reply.
Right, you send a port number, you ask for a port number and you get a port number, and then that establishes a path. But you can't assume that you're going to just talk to a particular port. You have to ask for what port it's going to be, because you don't know the availability on the two ends, what ports you're going to be allowed to use.
Well, I think Tom's talking about the reply from 1024.
Yeah, so yeah, there's,
it
there
doesn't
are
come by. anyway, these are details that we have to work out.
But the only broadcast one is the discovery. From then on, everything is
That's
Well,
from
that's
the
fine, but I still have to have a port I can send to you to say, hey, tell me what
Yes.
port I can get. I need a port to program you. Please tell me what that port number is. I have to
Yes.
have a way to do that.
Right.
Well,
Well,
the reply from the discovery gives you that port.
That's
I mean, I
right.
think it's all there in the protocol.
Yeah,
That's
but
built in.
but the machine in the FPGA doesn't have an Ethernet facility or a UDP facility, right?
well, how do you mean? It does have a UDP facility. That's what we're going to build into the FPGA.
We're going to have to build it. Yes.
Right.
Okay,
But
so I can't remember what the ports are. I've got to go back to the documents that we sent about 3 months ago, describing the problem that we were having, not being able to get
Yes.
one or two of the particular port
Okay, well,
numbers.
yeah, Tom, let's
We
talk
needed to
about
get-
that because I seem to remember that and it could kind of didn't get discussed because we were busy doing other things, but let's talk about
And-
that now. So,
By the way, at the time, I modified the HPSDR reply to add that port into the reply, the report, but you're still sending it to some place so that they can read what port to read it from. So it's a chicken and egg thing.
well,
I thought we had I thought we worked all this out a year ago and everybody was agreed on it. I'm
Yeah,
really stunned that everybody's saying there's something wrong with the protocol now.
because the thing is, if there's no port for the FPGA to respond to the discovery, then we have to modify the discovery broadcast to put a port number in there that he's listening on. If there is,
Yes.
so
And that
that he
I
knows
did
where to
that.
answer.
I did that with the Open HPSDR protocol that I was building with the simulator. So there is a way to do that, but
Okay, so Tom, let's unbury that and see if I just vaguely remember it. So it'd be good to get that taken care of, and so we all understand that we have it covered.
and by the way, Bill did a nice job of adding some additional diagrams to his document to explain who is listening and who's not listening.
And
So
where, right?
where that is a nice addition that you made in the last revision, Bill.
So, I mean, I thought, like I say, I thought we had figured all this out, and I'm really surprised to think that there's something unknown about this.
Well, it's not unknown. It's how do we translate what you did into the FPGA?
I mean, I know nothing about FPGA programming, but if an FPGA system is not able to communicate on Ethernet,
we're out of luck.
Yeah, I mean, there's got to be a way to do that. There's got to be libraries, or there's got to be some modules that you can call.
Very, very few.
Well,
you got to kind of think of giving up all the system libraries that you're used to.
We're going to write them ourselves in the FPGA. That's the only way to do it. And it's going to be much easier in Neos than it will be in state machines. So, I mean, realistically,
I'll try to resurrect the documentation trail. I was hoping we'd have a document that covered this, and we got about 90 or 95% of the way there, as my recollection. So
yes,
I'll try and resuscitate that.
It's when I'm sitting down looking at this again, I'm finding little things that, oh, this doesn't match up.
That we forgot or that we didn't specify.
Well, it all works in the simulator. That's not a problem. Bill has a working simulator, but the radio part in his simulator is sitting on a full-blown Linux.
Right, which means he has access to.
So we have to figure out how do we get things done that if you don't, you have C, but you don't have a full-blown Linux.
Right, and this is why I don't really want to implement TCP/IP, if we need handshaking, I want to use UDP because it's much
Okay.
easier to build. And the idea is that for the command and control, we use ACT UDP. We build our own fake ACT, which is only just one ACT. There's no retransmission. There's no TCP/IP hard stuff, because you got to implement that in the FPGA. And I don't know about you, but I don't really want to write a TCP/IP stack to run under NEOS. That's not going to be. It's kind of like Bill. Remember Bill Tracy? Not when people would ask him to write a sound card for the Janus board.
Yes.
And the first thing he would say is no. I mean, it was like not even in a discussion. Is I'm not doing that. If you want to do it, then you can do it, but I'm not going to do it. So it's just I don't want to make the FPGA code that hard because it's already going to be hard enough. And
that was the whole reason we went from USB to Ethernet, is nobody wanted to rewrite USB drivers.
Yeah.
I'm going to have to leave at this time and maybe try to continue this discussion by email.
Okay.
Okay. Thanks, Tom.
Bye-bye.
Tom. Yeah, I mean, I thought that was the reason we got rid of, but that was the reason why we went to UDP as well, because it simplified all the housekeeping necessary to do the communication.
Yes. And the UDP stream is much easier to generate. There's no ACKs, there's no retransmissions, there's none of that. So makes it a lot easier. Once I send the packet out, it's gone. I'm done with that one. Move on to the next. But some things like set the frequency need to be ACKed because it either gets missed or you ask for something that you can't have or that the radio can't do, then you got to be aware of that.
Well, and Bill, what I'm trying to do is at least write out some of the things that in your diagrams are not explicit, but are explicit in your code. And do it in a way that I can teach somebody else to do it.
Yeah.
Well, that'll be good because when you go to the next data engine that has a different FPGA on it, you have to port the code. You're going to want a spec to port to.
And so
a detailed spec. I mean, we have a process spec, but we really don't have all. I mean, you obviously covered the nuances because you got code that works, right? So,
and between Bill's code that works and some code that I wrote earlier or later last year, we have lots of the pieces, but we don't. We need to have it really clearly explained. This is what we're doing, and right now in the protocol, there's this little bit of cobbling that's two different kinds of protocols mixed together, which for somebody coming to this new without the history doesn't make sense.
Well, we need to clarify it and write it down. That's really important.
Yes. And it needs to be written down in enough detail that you can hand it to a programmer and they can write a piece of code.
Guess what? If you write it down, then you are going to figure out whether it works or not.
Right.
Well, so what would be helpful is if help me to, I mean, somehow let me know what it is that needs more.
Yes, I will be working with you on this.
And
but you were busy with this other testing this week, so I didn't bother you with it. But I was going to tonight start to talk to you about it.
Well, yeah, I mean, we may need a special workshop to set aside a couple of hours to have a Zoom call during the day or something. See what we can figure out.
So what I'm interested in is writing a document of what the data engine needs to be doing to listen to the protocol that you document. And that's where I'm trying to go right now.
In other words, the document to talk to the local host.
Yes.
Describe the data engine end of it.
Yes. And how it does that. And how it keeps track of where it is.
Like something that we never had for the Hermes board?
Nope. Never. Well, not well.
Not well, we won't get into that, shall we? Shall we not?
Yeah, no, I know exactly what you're talking about. And I didn't attempt it because having no experience in FPGA programming, anything I do would be garbage. We need to. So, yeah.
But I don't think it's really necessarily what can the FPGA do, even though it'll have to do it. It's really what needs to be done. I mean, it has to be done some way or other. And if you could do it with function calls to the Linux operating system, then you've got your code. If you do it with some other method that doesn't rely on those functions, so you have to dive deeper into what actually happens. And I guess you get down to
what are the actual, I mean, Bill has some of these where actual packets are going back and forth, but not all of them are there.
Yeah. So I think what's going to happen.
They are in the code because he's talking to some other protocols.
Well, what I think is going to have to happen is the NEOS processor is going to have to build the headers in memory, because that's going to have the port numbers and the IP addresses and all that, and the FPGA, and then we're going to use a DMA engine to stick the data part on the end and say, okay, now go send that. And then the FPGA takes it and says, okay, there's a block of memory. I'm sending that out.
Yeah.
And you've already made the front end. So I just send, I don't care what the data is. You put the data in place already.
But again, we also need to keep track of, there's a bunch of agreements that go back and forth, and those have to be stored somewhere in the.
That's right. And there's
in some sort of a table, basically.
And there's limited storage. So we have to figure out how are we going to deal with the fact that you run out of entries in the table, or I mean, that's going to.
It will probably be just some simplified code to know
And that's why I say
completed or not.
The acts are important. So for instance, if you ask for a new port and the table's full, then you get a NAC and you say, sorry, you can't have that because it's full. And in fact, we might have a reason why you can't get it. And one of the things I was toying with is, because we haven't defined this, but if I ask for a particular sample rate, say, and that's something that the hardware can't do, what the hardware can do is to tell me in the ACK what I actually got. So if I ask for some weird sample rate, 208 kilo samples per second, the NAC would come back and say, you got 192K.
Yes.
So, and we could do it that way, or we could just say NAC, and then you figure out what you did wrong.
Yeah.
Well, I did create a table of error messages. I mean, so I thought that, it could tell, the FPGA could tell us what is the reason why the problem, the request is being rejected.
Yes.
So, because actually maybe that's better, because if you give him a NAC, the implication is he didn't get what he wanted or didn't get anything. Yeah. So if you say I asked for 208K and you NAC it and give him 192K, well, that's not really a NAC then, is it? It's like a modified ACT. So maybe you don't want to do that. Maybe you want to say NAC incorrect baud rate or incorrect sample rate, and then he's got to go figure out what the correct ones are. So maybe then you have another query command that says, what are your allowed sample rates?
Right.
And then he can do that command and then pick one of those and then do another request.
So I had another question about the protocol. In HPSDR, we padded things. But if you have at least an end of packet, and we were talking about this.
He did that zeros. Because it was easy.
Huh?
Because it was easy in a state machine to take all the same size packets.
Right. But do we want to do that, or do we want?
Remember he had even on the discovery packet, he had like a 60 byte length packet.
Right.
I looked and I looked and I looked and I could find no mention of that requirement in Ethernet at all, ever, anywhere.
No.
And now he claims that he read that somewhere, that 60 bytes minimum was required.
Yeah, I remember that.
But anyway, so then the question is, do we need a 60 byte minimum there, or can we make the packets variable length with an EO end of packet?
Bill, you have multiple blanks in between things in your protocol. Could we just have an end of line value?
You could use, we've got a lot of latitude on what we do there, I'm sure. I mean, it obviously, if you're dealing with, you can make it easier for the Linux programmer.
That's what I would
you-
like to do. Is I like your idea of making it that you can use Netcat and talk to it.
Yeah, I mean,
I'd like to make it easier on the FPGA because you got a lot more resources on the Linux side than we got on the FPGA
Yes.
side. So for
But-
instance, I would like for when we receive a packet, I'd like an easy way to identify that this is a control packet now that's going to have to be parsed by the NEOS as opposed to just shoved out into the memory somewhere.
Right. Because
So
they're both, and this is what I want to do is document all these different types and when to expect these kind of packets to come
You're-
and when
you're
not to expect them.
you're kind of going to the next level because you know
Yes.
what Bill and I defined was a very high level, and they purposely left open so that you can have any kind of format you want as long as you define it ahead of time. Now it's time to define it ahead of time, right?
Well, and I feel like, to be fair to Kong, he's got to be able to understand what's coming at him.
I mean, he shouldn't be able to read our minds.
Yeah.
And in fact, to figure out the things that we didn't figure out. That well, anyway.
Yeah. So anyway, this is where I'm.
So you remember that cartoon where the scientists are looking at the blackboard and they have all these equations written, and in the middle it says, and then a miracle occurs.
Yes.
And the other scientist says, I think you need to be a little more specific in this step.
Yes.
So we've got the miracle occurs step with no definition of what that is.
So I'm trying to get the definitions and the flow sequence very, very clearly designed, starting from where Bill started. I mean, what Bill, if you were a normal programmer in a Linux system, Bill's got a nice description. But I think there's more detail that has to be explained for the FPGA.
Well, and maybe some of that detail is going to come about when we write the code. So Kong, you're on your own. You have to figure it out.
well, I mean, do we have a good handle on what libraries of functionality we have access to in the FPGA? Or in the NEOS or whatever sub.
We have very limited access.
It's going to be a little bit of standard lib, and I think that's about it.
Yeah, like for instance, you do have a printf function, but it is extremely huge, and you really don't want to use it. You rather use hitc and putc and do your own formatting. Because if some of those functions are really big and they take up lots of ROM to load, so you prefer not to use those functions, and you can pick which functions you want to use when you compile.
So you don't have to load the whole library. You just
No.
put in the functions you want.
We actually had one where I started out with printf and it wouldn't fit.
And it's huge.
So I had to take it out and put in getc and putc and format it myself. And it was fine because I don't need all the features of printf. It's just easy, right? Because we all know what that is. But when I switched it now, I mean, it cut the size like down by like 16K. I mean, that sounds like nothing to a Raspberry Pi, but that's big shakes to the FPGA.
Yes.
That's a lot of memory for it. So because it's in a library with a bunch of other stuff. So when you get rid of it, then you get rid of all those other functions that you weren't using anyway, because it says, oh, printf, okay, that's library A. We'll put it all in. And then you get all these other extraneous functions that you really don't want.
So anyway, I'm trying to diagram this out, and I think Bill and I need to work on it back and forth in email for a while, and then share what we get.
Yeah.
Is that okay, Bill?
Well, it's okay with me. My handicap is that I don't have enough experience with the FPGA. In other words, none, to know what's even reasonable to ask for.
So that's why we're going to talk about it.
But really, what the functionality we want to reproduce is the functionality of DE control and DE sim2. Those two C pieces.
Well, yeah, but that sounds like from what you're saying, that's a tall order. It sounds
And
like
that's using a whole bunch of libraries. Now, Kong, did you get a link to where those two files are?
The GitHub? Is it the one?
I gave you the GitHub where it was and the subdirectory to look in.
Are you talking about the documentation for?
Not the documentation, just the simulator. Did I send you that or not?
No, you just send me the
Okay.
link to the GitHub and the Hermes diagram.
Yeah.
Those were the two.
So I could share that C code with you. I mean, it's there. It's just, that's what we have to somehow reproduce. But it's a C program that simulates what the DE does.
well, it was intended to, I mean, I wrote that without knowing what limitations we have on the, I mean, we may have to make some accommodations or based on what the FPGA subsystem can do and can't do.
So this is, I think I can contribute here. And so what I'm trying to do is interface between the two of you to help, and then based on my HPSDR experience.
Yeah.
So anyway, I guess we scared everybody else off.
It was a pretty scary discussion.
Yes.
It was. So,
but I wanted you to understand that we need to do this or it's hard to make headway.
well, whenever you need to do a Zoom, I mean, let's do it.
Yeah. Let
You're
Bill
done
and
teaching, right?
Huh?
You're done teaching, right?
Yes, I'm done teaching.
Yeah. So
So
anytime, and anytime works for me too, other than times like tomorrow morning at 9 when I have a dentist appointment.
my wife had a dentist appointment this morning, so.
And Daniel, we're still on for Wednesday, right?
For a meeting with Kung.
Yeah.
Yeah, if you're able to do it, that would probably be good.
I should be able to do it.
Okay. Kung, do you have any questions or updates for them?
I do have some questions, but they're going to be very, very fundamental compared to whatever they were talking about before.
We haven't scared you off at least.
So I was looking through the Angelina code, as Dave mentioned before. So I looked at the functionality described by the comments in here, and it says that this will be the interface between let's see, the LTC 3208 to a PC.
Okay.
Yeah. So what it is, that is a piece of FPGA. I told him not to look at Hermes because Hermes won't load. You have to go back and get like Quartus 13 or something to load Hermes because it's written for a Cyclone 3.
But what you could do is you could just change the part to a Cyclone 5 and you won't be able to compile anything, but you can still look at the code.
But you can also go to Angelia, which is a Cyclone 4, and it's just Hermes.
Okay.
Okay. So I told him to look at the Angelia project, and you can go in there. It's just Hermes, but it's written for
Cyclone 4.
Cyclone 4. So then in there you can look at things, but you have to remember the protocol is going to be different, but in general you can see the structure of the code. There's a bunch of registers and a bunch of functions to take input and figure out where to put that.
Okay.
So, and then what I want to do is give you Bill's example that is written in C on Linux. And you should be able to read C on Linux, right?
Yeah.
And that code, he wrote it as a simulator for himself. So there's some things in there that are, you have to, they're a little cryptic, I guess I should say.
Well, the whole idea was it was just going to be a
Yeah, it was just a
learning
simulator
experience.
for himself.
Well, it's a learning experience to figure out the way Bill did it and the way Phil
Right.
did it. And
Yeah. And so then you've got Bill's code. And then what we have to do is figure out how to implement those steps in the at least part of the FPGA. So like the first thing is to figure out the discovery. So we'll send a packet, and when we get that packet, so we got to have some way to read an a UDP packet. And when we get that packet and parse it, and then then have some sort of answer. I don't know what this is, or yes, I'm the
Mac, right?
Yeah, right. So that's going to be one of the first tasks, is to figure out how to do that.
And then the next one is erase and program.
Yeah. Well, the race and programming is really simple, because you're just giving a block of memory and you're moving it to a different place. So those tasks are fairly
But you still have to
straightforward.
recognize the packet and
Yes.
put the memory somewhere and then program it.
And then put it in the place where it wants to be based on the max 10
And then
protocols.
pass a pointer to it, or you may end up having to write one location at a time.
Yeah.
I haven't found a bulk write in the max 10 IP library.
Okay.
It's a single, it's a 32-bit write, I think. So it's actually 4 bytes at a time.
Okay.
But it's not what you'd like. You'd like to just point a pointer to the buffer and say, load that sector, but no such luck.
Well, I saw something in there that you could use other protocols to move memory, and I didn't get very far with that, but it was
But
in
when it comes to, I'm talking about programming the flash.
the flash, moving things into the flash. There was if you switch to a different protocol, you can move bigger chunks of flash, it sounded like.
Okay, maybe, but I think I'm not positive of this, but I think that has to do with only with user memory. You can't do it in the program memory. Anyway, I may be wrong, but I mean, I know that we tried to do this with another customer, and we finally just gave up and did it one at a time because we could not find a utility that actually would work for max 10.
Okay.
So if we could find one, that'd be great. But I mean, we can always make a subroutine.
Well, let's start with that.
Yeah, and the problem being is that you have to be sure and act. You have to wait until every write is finished before you do the next one.
Right.
Otherwise, it doesn't work, and it's not clear in the code that that's what you have to do. But in the description of the function.
Yes. And we do need to run a CRC on the whole thing, which it sounded like is possible.
That's not hard at all.
So
you're just
but
XORing.
Really, the thing you need to be learning, Kong, is the max 10, the specific architecture relative to what you already know.
Okay.
And you did get Chord is 20.1.1.
Yep. Mm-hmm.
Okay. And I've put up all the documentation that I send to Kong. So if those of you who are still hanging around, you have plenty of spare time, you can follow along and learn it. So it's all under the DE in the TangerineSDR components link. That's it. We should stop because it's 2 hours almost.
We should stop before we're all scared off.
Before all of our brains melt.
Yeah,
I'm sorry I brought this up, but I'm getting nervous about this. So it has to be done to make our goal.
Yeah, one step at a time. We'll see how far we can get with the current proposed architecture and protocol
Right.
and see. I mean, the first step would be to make this thing come alive and be able to just simply respond to a discovery packet. I mean, if you can do that much, you've gotta, you're on the.
And that's kind of good. That's going to be required for the self-test, because the easiest thing to do to test the Ethernet logic is to just connect.
Connect to something, yes.
Connect to something, because if you can't do that, I mean, you can pass all the tests in the world, the connectivity test, but if you can't connect, it's useless. And my experience with Hermes, we had boards. I mean, we had boards that we could not connect to that everything looked perfect on.
Yes.
But yet we couldn't connect because there was I never did really figure out what the problem was on some of those boards. There was a handful of boards out of the 4,000 boards that we've shipped. There's a handful, and I mean literally like 6 or 8 boards that I could not get to recognize a discovery packet, and I could not figure out why. And I mean, it's only a few lines, data lines, because it's just connecting the chips, the PHY and the Ethernet and the FPGA together, and yet it wouldn't work.
Yeah,
it would time out. You know how the light would flash quickly, which says I tried, but I couldn't connect, so I'm timing out. And so, if you want some head banging experience, I'll send you some boards. You can see if you can fix them.
It sounded like component problems in there somewhere.
Yeah.
Well, and I'm pretty tenacious. I don't give up easily, because every other board we got 100% yield. So it really wrecks my record to have these 5 or 6 boards that I can't make work, and I don't know why.
Hermes boards?
No, they're what do you call it? Metis boards.
Well, even Nick Saban, he's had years he didn't win a national championship. So
Well, and you know what? Interesting.
There haven't been that many of them, but he has had those.
I think I know what's wrong, and it's probably best that they don't get fixed, because we had an area of the board between the PHY and the FPGA where I had traces go open. Now, those boards passed electrical test, so those traces were not open when they were fabricated, but yet they test open with an ohmmeter after I can't get the board to work.
Yes.
So it has to do with flexing of the board, hairline cracks that maybe got into the inner layer optical or something. And it's interesting that all of the 6 boards have failures in the same area. So it's this area of the board, a small little half square inch area that has inner layer problems. And I actually managed to fix 1 or 2 boards by adding wires. But it rapidly gets out of control, and you just can't put wires on every pin. So you just give up because it's not worth it. And we actually had a French guy bought a Metis, and he used it for a year. And then it just one day it wouldn't boot anymore. And so I said, well, send it back to me. And I looked, and it had the same problem these other boards did that had opens. And so I just sent him another board, because there's no way you can fix that.
I think I've got one of those.
Yeah.
I have one that I've run for 8 or 10 years, and it just stopped working.
Yeah, that's what happened to him.
And I can reprogram the FPGA, and it does it successfully, but it won't answer a discovery.
Now that's bizarre, because
Scotty, do you have the boards electrically tested when they're the PC boards when they're made?
Yes.
Yeah.
Yes.
I wonder if there's like a piece of dust on the Gerber or something like that.
Well, that's what I was thinking. And we actually took them back and had them x-rayed. I took them back to the CM, and I said, look, I got 5 or 6 boards that don't work, and it's all in the same area. Look inside and see if you can see. And they could not find anything. They couldn't find any cracks, any shorts, anything like that in the area that I told them to look. So, but yeah, we always pay for electrical tests. It's too scary to not do that.
Oh, I know, been there, done that.
So that's why I was surprised when I get boards that electrically don't work. You know, that's, how can that be? I had them tested. And especially ones like Dave's and the French guy's board that work for a year and then stop.
Yeah.
We had a bunch of boards that had hairline traces, and shorts in between traces. I got good at using a 5-volt, 20-amp power supply to blow them out.
That's the thing, is that you could detect those with an ohm meter, right?
Yes, those you could.
I couldn't detect them. I could detect opens. There were a few
It sounds
traces
like
that were
a trace just has a really, it must neck down at some point, and it
yeah,
fatigues.
Yeah.
And maybe it was over etched, or I mean, I don't know what happened. I mean,
anyway, we should stop. We're at 2 hours.
Look, there's one more little thing. Scotty, do you have another magnetometer that in your inventory you could send me? Nathaniel requested that I build up a second system to pair with the Grape.
Oh, okay. And Nathaniel, I sent yours out last week, so you should get it any time now. Finally,
Thanks.
huh?
Yeah, and it'll work out fine. Majid's on vacation this week, so he'll be back next week to work on it.
Okay. Yeah, so I have I think I have 5 more, Nathaniel, 5 more pairs.
All right.
So do you want me, I mean, I don't know where you have them earmarked, but they're just sitting here not doing any good. So I might as well send one to Bill if you can use it.
Yeah, no, definitely send them to Bill. So
yeah,
I think the people who have them seem to be doing good things with them.
Yeah. So Bill, do you need more than one set? Can you use more than one, or is one good enough?
Well, one more pair for now, and in fact, what I can actually do is we can have some fun with this. I can hook it up and get it collecting data on the Grape, but I can provide all of the data to Dave Witten's system, and we can do some comparison to see how the two different systems, if they produce the same results sitting in my yard.
Next to each other.
Yeah, I'll have them separated a little bit, but if they're basically within the same geographical area.
Well, Jules has hooked up some that with I think in the same pipe even.
Yes, he's got doubles in pipes, just trying to understand how similar they are.
So you could
if you put multiples in, you can do a wheelbarrow interferometer.
Yeah. The interferometer group has really gone. They're ready to design the next one.
So you want me to send you a couple of them? Is that okay, Nathaniel? I don't want to cut off anybody who's on the list for getting one, but it seems like they've been sitting there for a while. So
yeah, no, we don't have a particular list for these, so definitely send it to Bill.
Okay.
Yeah, just one more for me. I just need another, the base module and the remote module. I don't need a 2 pair. I just one set.
Yeah,
and it actually comes with a magnetometer, but daughter card too. So you have the whole setup.
Yeah, and then just hang on to the others, because there will be someone else who comes up and says, I need one because of whatever reason. Jules probably needs a 6.
You're just convincing me that for data engines, I don't want to be the one distributing them. So
that's fair.
Actually the Bruce, the guy from the Tapper office, has offered to be the mail order clearinghouse for all the data engine.
Oh, that's good.
Wonderful.
So we put them all in the box and send them to him, and then you tell him where to send the individual ones, and he sends them out one at a time.
That sounds wonderful.
Yeah, and then I don't have to do it. He's all set up for mailing anyway, so it's much easier.
Good.
Because we have to do it one at a time. Got to go find a box. That's why I'd rather send you 2, Bill, than send you one this week and one in 3 weeks.
Yeah,
I could put them both in the same box.
I mean, if you need that, if you need someone to do that kind of distribution for this stuff too, I mean, I can have Lori, our administrative assistant person, do that sort of thing as well. So
okay.
Yeah, she is very good at helping. But thank you for sending that to me. So I will look for that.
Okay. Hope it doesn't take as long as Bill's took to get to him.
Well, one idea might be try and find a way that does not involve using the U.S. Post Office.
Yeah, we send the first class, so.
That you're talking about weeks. I would suggest by sending it by FedEx.
I get stuff first class from DigiKey in 3 days.
Well, I don't
That's
know
because-
about how well things are coming out here to rural Alabama, but it took almost 3 weeks to get that magnetometer the last time you sent me.
I think when they see Tuscaloosa on there, they just throw it aside and wait a couple weeks, and then they bring it back out.
Must be a bunch of Auburn fans or something. I don't know, or something, but yeah.
Or it gets
seriously,
I think it gets to Atlanta and the Georgia fans just, oh, they don't need
could
this.
be. I don't know.
Well, I've
Anyway,
had
Nathaniel, we
a
said- I said-
package go from Concord, New Hampshire up to here, and you know, it's 60 miles in between us, and it went through Florida.
You could have
Well,
walked
yeah, I
up
mean,
there and delivered it.
Some of the systems they are sending to some facility out in Indiana to X-ray it for, I don't know, terrorism analysis or something. You know,
Well, isn't UPS's hub in Memphis?
That's
well,
for FedEx.
That's FedEx or UPS, one of the two.
FedEx is in Memphis and UPS is in Louisville.
right, yeah.
In
But
where?
in
Where's
Louisville,
Louisville.
Kentucky.
Louisville. Okay. Because I
But
know it seems very obvious. I mean, if you send something to Minnesota, it'll go to Louisville and then it'll go up to back to Minneapolis.
yeah,
It
but
doesn't-
on regular posts, I had one that came out of New York City, went to Indiana, then went to California, and then came back to Missouri.
Well, also,
I've seen that multiple times.
the U.S. Postal System and United Parcel System are working together. So we get a lot of things that were sent out originally by UPS that come into our mailbox, finally delivered by the USPS. So you have to bear in mind that it's not always just one organization handling it anymore either. So
So on top of that, I ordered a part from Shenzhen, China, DHL, 1 week, customs and everything.
yeah.
How does that work?
Well,
Hey, I
maybe,
ordered a.
Scotty, if you send your stuff to me via China, maybe I'll get it sooner.
I ordered an antenna for my truck because the little whip antenna fell off. So it's like what, 36 inches of whip, right? I ordered it from Shenzhen, China. It was like $8.
Yeah.
It didn't arrive for 3 months. I filed a complaint and I got my money back.
Oh,
And then the
wow.
thing shows up like a month later.
Oh, of course, right. Yeah.
Okay, so anyway, I sent that, Nathaniel, to your Scranton address. So I don't know if that will add any time to it or not, but it's your university
Okay.
address.
I'm going to say
Maybe
73.
you want to close the net as I'm falling asleep.
Yeah.
73, going keyword.
All right.
73.
I
all.
agree.
Thanks.
Take
7-3.
care. We'll be in touch.
73. Bye.
Bye.